hope that you can do when you come away from this presentation, it's going to be science-based and it's also going to be very clinical. What I'm hoping that you can do is take away some of the tables, the charts, the figures into your clinical practice to help your patients to eat smarter. Not harder, but smarter, and make the better choices. So we definitely want to help our patients in many ways, and that's how I've really constructed many of these slides. I spent a lot of time going through the USDA database, really calling together what are the high phytonutrient dense foods. So you will see those appearing in the presentation. So Dr. Bland on the first day had talked a lot about the gut microbiome, talked about food as information. We definitely have seen a transition in the whole aspect of the nutrition field, right? So when I went to school back in the early 90s, it was food is calories, food is energy, which of course I'm sure none of us can argue with. But in the 21st century, as we saw from Dr. Simopoulos' talk and others, there's much more to food than just the caloric aspects. I would say that that's one level, that's one dimension. And what we're seeing now is that I really like what was said about food is hormone. Food is information. Food is cell signaling, that there's a lot going on at the level of the cell as we take in information and assimilate it. So as this article from Dr. Bland states, we are witnessing food being redefined as information that alters cellular function in the postprandial state. So I would say that if you look at our eating, and it's really interesting because I bet if you ask your patients whether or not they eat healthy, many of them would think that they do, right? It's all subjective. But if you really take a survey and look at the meals that people are eating every day, I'm not just really looking at fat, protein, and carbohydrate. I'm looking at color. And if we look at this sample plate, the standard, it's not even American diet, it's the standard all over the planet diet is what I'm calling it. Because I've been to South Africa, I've been to Australia, I've seen how the Taiwanese eat. They probably eat the best out of all of them. But we're starting to see this epidemic of color deficiency, phytonutrient deficiency. So we're consuming a lot of the brown, yellow, and white, and we're not seeing a lot of the complex colors come through. So why should we care about phytonutrients? Why should we care about colors? What I think is really important is that whether we're an omnivore, we're a paleo eater, we are a vegan, we're a raw foodist, we're a vegetarian, one thing that everybody in this room, I'm assuming, can come together on is plants. Who can argue with plants? An intelligent species, they have to defend for themselves. We take their nutrients, we're able to metabolize those nutrients into even more efficacious compounds, and the science is impeccable as it relates to the epidemiology work. If we look at prospective human clinical trials, we see very compelling data to support the use of phytonutrients for several different chronic disease states. These phytochemicals, just to give you a little bit more of a definition rather than just calling them colorful compounds, which they are produced by plants. This is part of their lifespan. So these can be carbohydrates. Fiber, we might want to lump fiber into the phytochemical bucket, right? Proteins, different carbohydrates, vitamins, minerals. But what's really intriguing are some of the other phytochemicals, the secondary metabolites, that I think we still don't have a lot of information about, right? These things are still being identified, quantified, discovered, and put on the radar for us. And at last count, and this was back in 2007, this is about as good as we have to this point that I can determine, it's been estimated that we have something like 5,000 to 10,000 different phytonutrients in our food supply, which is great, big, huge, right? That's a lot. So it's not as easy as just calling these different compounds phytochemicals. There are different families within the different phytochemical branches, right? So we have the phenolics, which are probably the most common ones that many of you have heard of. The phenolic acids, the stilbenes. We heard a lot about resveratrol. The flavonoids, things like quercetin, luteolin, epigallocatechin gallate. We did hear about green tea and its benefits. So that really falls into the category, the very large expanse of what we call phenolics. There's also alkaloids, where we have caffeine, nitrogen-containing compounds, organosulfur compounds, things that are stinky because of the sulfur compound within, so the indole-3-carbinol, the glucosinolates and such. Phytosterols, which Dr. Mark Houston talked about, also found in plants, and carotenoids, which I probably have the most familiarity with. The fact of, even though you only see 7 different carotenoids shown here, there are upwards of 450 different carotenoids. So the complexity is really immense and really something for us to grasp in the nutrition community. And it's not just the qualitative aspects of phytonutrients, but then there's also the quantitative aspects. If you were to sum up what an average person gets in a day of these phytonutrients, it would be something on the order of about 1/3 of a teaspoon. Very small amount relative to the many gram levels of carbohydrate, protein, and fat that we take in. In fact, Walsh and researchers published in 2007 a very interesting study where they controlled for calorie intake and only modified the phytonutrients. So they had the same macronutrient profile and only changed the phytonutrient level. And this was an acute study. And what they showed was that just after 2 days, the metabolomic profile that was shown in the urine, a lot of the liver metabolites had changed dramatically just with this introduction of a very small amount of phytonutrients. So it may not just be the quantity, it may be about the different phytonutrients coming together in that complex. So for a very long time, we've heard of these phytonutrients referred to as antioxidants, which they surely are, and that was really great literature in the 1990s, really fortifying that position of these plant compounds. And what I would say is that we've really gone beyond thinking about these plant compounds as antioxidants. Indeed, they serve that function, but what we're finding is that these phytonutrients seem to localize in certain parts of the body and have a functional role. So what does that mean exactly? Well, if you look at a very simple one like lutein, localizing in the back of the eye into the macula, very specific to the function of the retinal tissue. One that not many people know about is beta-carotene localizing in the follicle within the ovary, right? So why do we get the maturation of the follicle to the corpus luteum? Well, corpus luteum refers to yellow body or the concentration of retinol that is within that tissue. So one thing that I've often thought of is the reason why there are so many issues with chronic disease and even things like infertility, because we don't have the complexity of phytonutrients in our diet. So phytochemicals do modulate, and we've already been talking about that, especially yesterday morning. We really touched upon this on the epigenetic level. So not just the basics of antioxidant action, localizing in tissues, but there is also an epigenetic effect. In fact, in this paper, which just came out this year, they were talking about emerging bioactives within the nutritional arena. And phytochemicals were listed as one of those, what they're calling non-essential nutrients. Along with things like zoochemicals, fungochemicals, and bacteriochemicals. So what I think is going to happen in nutrition is we're going to see this degree of really going deeper into certain classes of compounds to really understand the complexity of food, that it's not just one substance, it's not just one macronutrient. We need to look deeper at the complexity. And I think that the reason why we've seen a lot of inconclusive results could be because we have not gone deeper. We have not gone deeper, and that could be because of various reasons, whether measurements, analytical changes, and such. So I told Dr. Bland that his talk perfectly set me up to talk about phytonutrients, because one of the things that I'm seeing more and more is that the nutrients that we take in from plants are good, but they're only as good as our gut microflora. In fact, I think of this even with soy isoflavones. A lot of contradictory evidence on soy. We heard about soy earlier as it relates to pain. Of course, there are different types of soy. But what's not often discussed in these clinical trials and in this research is what is the gut microbiome of those people, right? And how does that interact with the soy isoflavones to create different metabolites, right? So didzine being converted into Equal as a result of the interaction with the gut microflora. So I think it's really important for us to think as clinicians about not just getting more color into our patient, but to have a landscape, to really have a good gut ecology to allow these phytonutrients to come in and really be metabolized to the utmost. Because if you look at the flow of nutrients coming in to the intestine, what you see here is that a certain amount can get absorbed. You have interaction with the gut microflora. You also have metabolites that go through phase 1 and phase 2 processing by the liver. And so you have a whole host of very different metabolites that can come through, which can also be why sometimes if we take in certain plant foods, we may not see a trace in the blood because it's been converted to another metabolite. So again, really good to look at the complexity. So since Dr. Bland and I are very interested in the whole role of personalization as it relates to human nutrition, especially in the 21st century, we know we're getting there because of all of the popularity of gene tests and really looking at genetic variants. And I think that out of all the lifestyle medicine approaches, probably nutrition is the most primed and ready for this type of introduction. And it's not just us talking about it. There are other groups that are really talking about how do we move towards personalized nutrition. I found this article very interesting because they were marrying together not just looking at personalized nutrition on the whole, but also looking at really going deeper into personalizing phytonutrients, doing what's called phytoprofiling. Can you imagine that you would go into your clinician, get your genes typed, your epigene typed, and then you can see, based on the different plant compounds that you are surrounded with in your living environment, wherever you live in the country or on the planet, that you could match somehow your phytonutrient intake to your gut microbiome and your genetics. So this article was really pushing us in the direction of really thinking about that, envisioning that out for nutrition. So where are we now on the spectrum? Well, I know what we had for lunch, so it's not fair to ask you because we did have a colorful array. But if you ask your patients and even survey them, and one of the very basic things I do is I have them do a food log. And if I'm doing this in a group and doing a teaching or a workshop, I'll have them exchange food logs and just simply point out colors to each other. And this is not something only that I have done, but others have quantified as well. What we're seeing is that most Americans, 80% of Americans, are having some type of nutrient colorful gap. We're missing phytonutrients, 80% of Americans. And if we look at the different colors, what we see is that we're missing some more than others. So blue-purple is probably the one of most concern, with 88% of Americans falling short in that particular color. So indeed, we have a color deficiency, is how I would classify it. And if you look at the 2010 dietary guidelines for Americans, what we see is that the recommendation is for 9 servings of fruits and vegetables. That's based on a 2,000-calorie diet. However, I've seen different ranges. I've seen that the average American gets somewhere between 1.8 to 3.6 servings of fruits and vegetables per day. So we're far off from where we need to be. Many people get confused as to what is a serving. So this is another one of those clinical pearls and teaching points, right? It's not just, there's a lot of literature coming out on the bioavailability of phytonutrients. Does everything have to be raw? No. In fact, even in my graduate work with Dr. Bowen, we found that she was working on lycopene and beta-carotene, and we did a lot of the early work showing that cooked lycopene fared much better when it came to looking at serum levels than did raw tomatoes and looking at lycopene from that source. So really looking at the whole host of different ways, not just to get phytonutrients through the foods that we're eating, but how we prepare them is important. The work of Dr. Christakis and Fowler at Harvard and at Stanford in their book Connected really got me thinking about the power of social networks. We're starting to see more and more studies focused on the sociogenome, the complexity of our different interactions. So you could say, well, how does that trickle on into what we're eating, even in terms of phytonutrients? And what's very interesting is that there was a study that just came out this year in August showing that our social networks will determine to some extent whether we eat fruits or vegetables. There are certain groups that are more vulnerable to this than others. For example, men who live alone tend to have a lower intake of fruits and vegetables. And also, your friends, your social gatherings can determine whether or not you will be more apt to drink alcohol or have certain kinds of snacks. So I think it's really interesting to see what's percolating up in the research as it relates to social networks establishing eating behaviors. So how do phytonutrients work? It's pretty complex, and I know that we've already seen a number of mechanistic slides which would allude to how they are working. I like this graphic the most because I think it says the most amount of information with the least amount of arrows and pathways, but it really does get at the essence. So since this segment is really focused on inflammation, what you can see from this is that a lot of these plant compounds have anti-inflammatory effects. So they decrease inflammation, they get into the different cell signaling cascades, not pathways, as Dr. Bland pointed out. These are networks, these are webs within the cell. So moving through and really trickling and making a difference on inflammation. They can also make a difference as it relates to energy utilization, so changing things like insulin sensitivity. So when we hear about things like type 3 diabetes, thinking about insulin activity in the brain, there are some really nice studies even looking at how the different plant compounds can change brain receptivity, neuronal plasticity as it relates to insulin. And then stress response, looking at things like cortisol, which is very much connected to insulin, right? Which is very much connected to inflammation. So sometimes clinicians get confused and they think, well, should I be working on inflammation in that patient or insulin resistance, or should I be working on their stress response? And the answer is yes, right? You work on any one of these, you can see that they're all intertwined. You work on inflammation, you're going to have an impact on stress. You work on stress, you're going to have an impact on insulin. So the beauty of these plant compounds is that they can get into these different systems and really have this ripple effect. This was a short-term study. I like a lot of these short-term studies because, again, it shows us the power of what we do in the moment of a meal, the acute meal setting. And as Dr. Bland had pointed out in his talk, just one meal can provoke something like acute metabolic endotoxemia. So how can we negate potentially some of those effects with phytonutrients? Can we? So this study was in healthy people, 19 women that were non-smokers, and they went on either a phenol-rich or a phenol-poor diet for 3 days. And what they showed is that just after 3 days of having high amounts of phenols in their diet, they were able to increase their levels of superoxide dismutase by 41%. So this, to me, is like the carrot for the patient, right? That you can really feel a difference in your health just within a couple of days of implementing more color, implementing more of these plant foods. So I mentioned that these phytonutrients are often referred to as antioxidants, but they may have pleiotropic effects. One of the effects of these phytochemicals that we discovered in our lab and also through our clinical work is that they can have effects on gene expression, where they can key into the antioxidant response element, which can also be linked to production of metallothionein. So we're looking at heavy metal metabolism, we're looking at phase 2 induction by the liver. And so really looking at protection by the body against a number of different sources in the environment. Also, how, and I know that probably the question or the comment during the panel will come up about organically grown food and produce versus non-organically grown, right? And so we have this whole idea of stressing plants, that stressing plants can help to produce more of these beneficial secondary metabolites than unstressed plants. You know, sometimes I think even with the message around organic versus conventionally grown food that it has become more simplistic, that we're just thinking about reducing pesticides, insecticides, and herbicides, which is all very good, of course, because there's a correlation between those organic pollutants and things like type 2 diabetes. But another thing is important to realize, which is that if we're cultivating that sense of stress from the plant's inception, then from birth, that plant is really structurally, biochemically different, aside from just not even having the pesticides, insecticides, and herbicides. So the way I see it is it's one way to eat smarter. It is getting more nutrient density. This was a study in 2003, and of course, many of you probably realize that the literature on organically grown food versus non, it's a little bit inconclusive. There are studies going back and forth, really trying to argue the point of yes, organic is better, or no, it's not, and you have to look at who puts out the studies, what are the interests, but essentially this is one study that I found very interesting because they were looking not just at organically grown food, they were also looking at sustainably grown. And if you'll note, sustainable was as high in one case, if not a little bit better in certain nutrients, at least in these two particular foods, Marion berries and corn, as was the organic food. So that's why we have groups like the Environmental Working Group really working to promote this message of cleaner eating or having less residues on food. One of the aspects that I really would like for you to take away and to think about from a clinical perspective is the whole idea of botanical diversity. You know, many times what I'll see with patients is we get into eating ruts. We start eating the same thing day after day, the brown, yellow, white, or maybe it's just one of those colors, maybe it's red, or we don't get the complexity. And if you think of Dr. Bruce Ames's theory about the triage theory, right, that any one particular biochemical series of networks is going to be determined by, and rate limited by the amount of nutrient that's present in the lowest amount, what you really want to do is to have the diversity of different nutrients, that seems to fare much better, and the science supports that. This is a study, again, just published this year, looking at cancer. Definitely an area of focus for us at PLMI, and also personally, I have an interest in really looking at cancer as it relates to these phytonutrients. And what you see here in this very colorful profile, just to quickly walk you through it, if you look at the first profile, this is untreated control, and these are cells in which they were looking at various kinases and applying certain phytonutrients just to see what would turn on and what would turn off. And you can see at the bottom they talk about gene expression. So the blue color refers to low gene expression, yellow refers to high. So the untreated had high gene expression, genes turned on for cancer, and then as DHA was added, you can see that there was a little bit of a shift there. And then when curcumin was added to that same cell line, you see a cooling or a dampening down of the oncogenic response. And then when you put both of them together, it seems to be potentially additive or maybe even synergistic here. So there may be something about the layering effects of certain phytonutrients, coupling certain phytonutrients together to achieve a certain effect. So I'm sure many of you know about glycemic index. There's also the phytochemical index, PI. And the phytochemical index, the way that you would read this is a little bit opposite of the glycemic index. Glycemic index you want to be low, phytochemical index you want to be high. You're looking at the amount of calories supplied by nutrient-dense foods over the total amount of calories. So many of the research studies that are coming out now are looking at phytochemical index as a very objective way to assess what people are getting in the way of phytochemicals. In this study published in 2010, they compared normal weight individuals to those that were overweight, and what they found was probably what you might anticipate, that the normal weight individuals had higher levels of different plant foods in their diet. They also had higher levels of phytonutrients in their blood, and the phytochemical index was greater of the overall dietary pattern. If we look at inflammation specifically, that same study assessed whether or not PI, phytochemical index, was correlated with a number of different inflammatory markers. And they did find a trend for C-reactive protein, IL-1, and IL-6, showing that with greater PI, more phytochemicals, we see less inflammation. There's also a more recent study in 2012 looking at phytochemical index and obesity, showing that there was an inverse association, again, between PI and levels of obesity. So the greater the phytochemical index, the lower the incidence of obesity. Here was a study on breast cancer. So showing that for women that consumed higher amounts of fruits and vegetables and other foods that would give these phytonutrients, that they had reduced risk of breast cancer relative to women that had a lower PI dietary pattern. Diabetes. I'm kind of going through all the different chronic conditions, right? So looking at cancer, in the case of diabetes, we also see that things like green leafy vegetables, and I'm going to talk very briefly about why this might be. It's very interesting, the newer research coming out on bitter greens and what we're seeing there. But that green leafy vegetables reduce the risk of diabetes. In fact, here's another great clinical tidbit, something to mention to your patients, that increasing their servings of vegetables by just a little bit more than one can reduce their risk of type 2 diabetes by almost 15%. And what's a serving, right? It's just half a cup, or if it's leafy greens, 1 cup. If we look at cancer, the other piece that I wanted to bring up is that there may need to be some tailoring. Here's where we see that flavonoids, one of the individual phytonutrient types, that there's a little bit of a different response depending on the type of cancer. So very good receptivity when it comes to cancers of the nervous system and cancers of the lung, and I would say even urinary organs and colorectal, but perhaps not the same robust effect in some other cancers. So this is, again, why we need to personalize, why we need to look at the different chronic conditions, look at the patient type, look at their genetics, and then match to different phytonutrients. Dementia. Most people are concerned with not having mental sharpness into their older years. And so one of the very easy things that we can do is to increase our flavonoid intake. This study in particular showed that there was a 41% reduced risk of dementia with higher dietary intake of flavonoids. So if you put it in perspective, 1 cup of black tea or green tea provides a hefty dose of flavonoids to really give you that over that threshold that you would need to help blunt dementia occurrence. There are even great studies on bone health showing that the balance between osteoblasts and osteoclasts as we get older and how that starts to change when we start to get more osteoclastic differentiation and activity, that can also be modulated by fruit and vegetables. So that might be due to some of the alkalizing effects, that might be due to some of the more specific phytochemical effects. So I'll just take you quickly, because again, I'm thinking of the patient and how does this information get translated by you into everyday work with patients, with clients. So if we look at the red food phytochemicals, there are a number of different ones. There is definitely lycopene. Dr. Mark Houston talked yesterday about how lycopene may be responsible for better functionality of HDL. So there was a study that came out looking at different amounts of lycopene doing that. Anthocyanins, astaxanthin. So a number of these different, and again, these are just 3 phytonutrients, but there is really a complexity. In the New York Times this year, there was a wonderful array of different profiles looking at nutrient levels of different foods and comparing them against each other. And again, this is where we think about eating smarter. Where can we make the best choice? So you can see here, with the smaller numbers being an indication of how much in the way of phytonutrients, you can see that apples like Ginger Gold and Golden Delicious have lower amounts of phytonutrients than even something like a Granny Smith or a Gala apple. So very different. And of course, the smaller the apple, the more tart it is. Typically, the higher it is in these phenolics. Orange, of course, many different types of compounds to talk about. The ones that get the most recognition are things like beta-carotene and bioflavonoids. And what the USDA nutrient database just recently, I would say, I just saw it this year, had put up some nutrient analyses for things like proanthocyanidins, for isoflavones, for carotenoids. So now you can actually get in and get some details on different foods. So I just happened to go through some of the different foods and put them in the order of greatest concentration of carotenoids, and this is the sum of all carotenoids. This is not just beta-carotene. So you can see that things like dehydrated carrots and kale and spinach come to the top. And back to the idea of bioavailability, if we look at something like beta-carotene, it was always such a great thing for me to be able to say to people that you can have some fat with your carrots. Or if you want beta-carotene, you need to have some conduit of oil in order to help the fat-soluble beta-carotene be absorbed. So this was an interesting study. It was an in vitro study using a spinach homogenate, different types of oils, and then looking at the absorption, the bioaccessibility, and showing that the different oils may have some impact on the bioavailability of beta-carotene. Now, when I say beta-carotene, you might think of carrots, but this study showed that papaya actually provides a greater bioavailability of beta-carotene than from carrots or tomatoes. And also that lycopene was more bioavailable from papaya as well. So sometimes it's not always the foods that we think that are giving us the most nutrient bang for our buck. Spices are one of the, I see the spice cabinet as an herbal pharmacy in our kitchen, and I believe that if we talk about the Mediterranean diet, one of the things that we leave out oftentimes is the copious use of spices, the vast array, and again, the complexity of different spices coming together. There is so much great work on spices. I have a whole lecture series just on spices alone, but I just thought it might be interesting to look at just one example of where we can make an impact, where we can, again, take this information to the patient. We know that with cooking meat, we form all types of different products, some of which are carcinogenic. And by adding in spices to the ground hamburger meat, and there have been a series of studies, this is not the only one, where they're looking at different applications of certain amounts of spices to meat, cooking it, and then comparing the levels of heterocyclic amines and finding a reduction in HCA production based on the incorporation of these different spices. So in this particular study, turmeric, fingerroot, and rosemary were very effective. I do see a number of studies on rosemary specifically. So there are a number of yellow-green food phytochemicals, too many to cover within the scope of this talk, but there are certainly a number of actives within green foods that we need to pay attention to. I've already mentioned lutein, which is actually yellow, the indols, like indole-3-carbinol, which can have some effects on hormone modulation through impacts at the hepatic level, chlorophyll, what I call phytomethylators. Dr. Stone talked about methylation today, phytosterols, and phytoestrogens. So one case in point as it relates to what is a good food source of lutein, if you look at the comparison, and I bet most of you were thinking kale after I just said that, right? You're thinking, well, of course, kale is the source of lutein. But if you look at this study and their comparison, their analysis, parsley is actually quite comparable with kale. So, how do we get some other complexity in the way of food choices? I love this study by Dr. David Heber at UCLA showing the power of just having half of an avocado together with a hamburger really helped to blunt a lot of the vasoconstriction effects and a lot of the inflammatory effects, the increases in IL-6 that happen after having the hamburger postprandially. And avocado is one of those power green, yellow foods. I don't think many people realize that a full avocado contains a hefty amount of fiber and more potassium than a banana. One of the latest types of foods that is getting more and more attention is microgreens, which are, again, very nutrient dense. These are not sprouts. Sprouts come up within 24 to 48 hours, and you get a seedling. Microgreens are the actual leaflet that you get after about 7 days of growing in soil. All of phytochemicals, if we're thinking yellow-green compounds, what I'm seeing in the literature is, yes, lots of data on cardiovascular disease, anti-inflammatory effects, and extra virgin olive oil being essential. But also what we're seeing is that perhaps it's not really just the monounsaturated fat, but it could be a lot of these actives that reside within the oil itself. So I always tell patients that if you have a little bit of an unrefined cloudy oil, that could be a good thing, that there are some studies looking at that. And we know that these olive bioactives have been studied for their anti-inflammatory effects and also their ability to upregulate the phase 2 genes. All right, bitter phytochemicals. Just quickly go through this. This is really exciting, new information. If you think of the types of foods that are bitter, things like arugula, caffeine, green tea, soy isoflavones, what we're seeing is that we have these taste receptors throughout our body. Not just on our tongue, but we have these T2 receptors also in the small intestine. This work comes from Dr. David Cummings at the University of Washington. And so essentially we're tasting in our gut. And our ability to taste may say something about our metabolism. So what we see is that even polymorphisms in these bitter taste receptors, and there are many different types, there are 25 plus types. We also have them in the brain, we have them in the reproductive tract, we have them in the airway. And what we're seeing is that there is a correlation between polymorphisms in these receptors and the degree of aging, how well we age, how well our antioxidant defense system works. Now, back to what I was saying about type 2 diabetes and looking at green leafy vegetables, what we see is that bitter plant compounds do help to modify gastrointestinal physiology. So when we stimulate these receptors with these bitter compounds, we can see changes in gastrointestinal motility. We can see changes in gastric secretions, in secretions of the pancreas, gallbladder contraction. So I often wonder whether or not our whole panoply of different issues with the gastrointestinal tract aren't in some way due to the fact that we're not stimulating these gastrointestinal receptors with the proper phytonutrients.